can we build a consciousness meter? So when it comes to neurotypical human beings, people like you, people like me, normal adult Homo sapiens, we know that such individuals are conscious. So the philosophical problem of other minds is how we know that other people are conscious. That's not my topic here. I'm setting that issue to one side. We know that normal human beings are conscious. We know that bricks are not conscious. We know, or at least we think we know, that iPhones are not conscious, and it's not just Apple products, also Samsung are not conscious. But there are a lot, so those are the easy cases where we think we know whether an individual is conscious, and we know that they're not conscious. But there are lots of hard cases. And the scientific problem of other minds is working out whether consciousness exists in the hard cases. So non-human animals, birds, reptiles, many kinds of mammals. There's genuine uncertainty about the presence of consciousness in organisms like that. There's the fetus, so very young children, genuine uncertainty about consciousness at the early stages of development. And there's uncertainty about human beings who have suffered some kind of brain injury. So I'm actually going to talk quite a bit about a certain class of brain damage patients, patients who have come out of a coma, post-comatose. The kinds of things that we use to ascribe consciousness to other people are absent or only problematically present in non-human animals, in the fetus, or in brain damaged patients. So the question is, can we go beyond those measures and find other ways of identifying, measuring the presence or absence of consciousness? And in particular, there are two ways in which we might go beyond our pre-theoretical measures. We might ask, can our pre-theoretical measures be supplemented? So when they're silent, when we don't know whether the pre-theoretical measures hold, are there theory-driven measures that we can use? And can they be trumped? So could we have a situation where our pre-theoretical measures say one thing and our theory-driven measures say something else? So can we supplement our pre-theoretical measures, and can we trump them? And I'm going to tackle both of those questions together by asking the question, can we build a consciousness meter? So before I get to that, let me say a little bit about what a consciousness meter would be. And before, so what we need to do is distinguish different types of consciousness meters. And to do that, we have to work with a taxonomy of consciousness. And here's the taxonomy I have. It's a toy taxonomy. It's a very simple model, but it will hopefully be useful in orienting our attention, to use Francisco's term. So here's how I think of things. I think there's a general property, what I call a determinable property of consciousness. And I tend to think of that in Hegelian terms, like Francisco was saying, in terms of there being something it's like for the organism. We can come back to that notion. We will come back to that notion, I'm sure, in the discussion. So that's the highest level property. That's the determinable property. But there are then two ways in which you might give a more fine-grained analysis of a creature's conscious state. On the one hand, you can divide the kind of conscious states the creature's in terms of perceptual states, affective or emotional states, and various cognitive states, various states of thought. So I have a visual experience of the clicker. You have auditory experiences of my voice. If you've been drinking coffee, you'll have various olfactory, gustatory experiences of the coffee. You'll be in an emotional state of a certain type. You may have certain conscious thoughts. So all of those sorts of states are ways in which your consciousness is modulated, and those states are individuated by appeal to their contents. Then, so those are often referred to as contents in the scientific literature. But there's another kind of distinction which is relevant here. We can distinguish the state of normal wakefulness, which hopefully most of us are in right now. There's various states of sleep, REM sleep, non-REM sleep, characterized by different kinds of dream states. The states of light anesthesia, where you might be drowsy. There's hypnosis. So there are various kinds of general states of consciousness which are not individuated, not characterized in terms of their contents. So these two distinctions cross-classify. What to call these things in the middle is an open question. The neuroscientists and the neurologists call them levels of consciousness. And we'll come back to that term later. I don't like that term. I've written a couple of papers saying why I think it's unhelpful, but it is a very commonly used term. Some people call these global states of consciousness, and I tend to find that term quite useful. David Chalmers has called them background states of consciousness. They're not focal in the way the contents of consciousness tend to be, but I find that distinction, that terminology also has some problems. In a paper that I'm just doing the proofs to, so it's going to be published soon, I call them modes of consciousness, but I've now changed my mind. I don't like that terminology, but it's too late to change the proofs. So these things get called different things. We're going to call them either global states of consciousness or levels of consciousness. And one could have a consciousness meter for each of these things. So you could have a consciousness meter which tells you about consciousness but doesn't tell you what kind of global state of consciousness a creature is in or what kind of contents. Or you could have a consciousness meter that focuses on contents and particular kinds of contents. So it might tell you about visual experiences but not anything else. Or it might tell you the kind of global states that a creature's in without telling you what contents it's in. So a consciousness meter could measure different aspects of consciousness. Note, however, that there are various logical relations between these components of the taxonomy. So because these states are determinants of this state, if you're in a particular conscious state, you're conscious, necessarily. So any consciousness meter that focused on one of these would be a consciousness meter for consciousness as such, in a sense, right? If it tells you that you're in that, it tells you that you're in that, but not vice versa. You could have a way of measuring that something was conscious without knowing what kind of conscious contents it has. Lots more to say about logical relations between different aspects of this taxonomy, but that's enough to get us going for now. I want to move on. Okay, so 3 attitudes to the question, can we build a consciousness meter? I call pessimism, quietism, and optimism. So the pessimist says you can't build a consciousness meter. And I want to distinguish 2 types of pessimists. A metaphysical pessimist and an epistemological pessimist. The metaphysical pessimist says you can't build a consciousness meter because you can't have a consciousness meter. There's no such thing. You can't build it because there couldn't be one. Why might you think there couldn't be a consciousness meter? Well, suppose you have a kind of Davidsonian conception of consciousness, which wasn't really Davidson's. So suppose you think Davidson's view about intentional states is true of conscious states, in that there are no nomological, no principled correlations between physical states and conscious states. No correlations at the level of properties. So suppose you think every conscious event is identical to a physical event, but the properties, there's no correlation between the properties. If that's your view, then it's hard to see how you could have a consciousness meter. There would be no physical aspect of the world that's correlated with conscious aspects of the world, so you couldn't have a machine that measured the presence of consciousness. So if you have that kind of view about consciousness, the kind of view that Davidson has about thoughts and intentional states, then you would have a reason to think that you couldn't have a consciousness machine. There may be certain views in the metaphysics of consciousness that come out of Russellian conceptions of panpsychism, of neutral monism, which may also create problems for the existence of a consciousness meter. I'm not going to talk about those anymore, but I think there are possibilities to think about there. I'm more interested in the epistemological pessimist, who says you could have a consciousness meter. Sure. You just can't build one, or at least you could never justifiably take yourself to have built one. So even if God gave you a box which measured consciousness, you couldn't have good grounds for thinking that it measured consciousness, even though that's what it does. There's some deep principled problem with thinking of a machine as a consciousness meter. And this is the view that I'm really interested in. So, who is an epistemological pessimist? Who have I got in mind as someone who's an advocate of that view? Well, I think you can find this view in some of David Chalmers's work. Actually, I think this idea is quite widespread, even though there aren't that many people who have explicitly endorsed it. I think it's quite common, but the closest I've come to an explicit advocate of the view is Chalmers. So here's a passage where he talks about the use of the neural correlates of consciousness to function as a consciousness meter. So he says, and he thinks you can't build a consciousness meter using the neural correlates of consciousness. Why? The primary criterion for consciousness will always remain the functional property that we started with. Global availability, variable report, or whatever. So you start with a functional property such as the global availability of information for voluntary control. Something like that. That's how we discovered the correlations between consciousness and 40 Hertz oscillations in the first place. So the background here is an idea in the science of consciousness, which was popular about 10, 15 years ago, that 40 Hertz oscillations in visual cortex is the neural basis of visual experience. 40 Hertz oscillations are relevant only because of the role they play in satisfying this criterion. True, in cases where we know that this association between the neural correlate of consciousness and the functional property is present, the NCC might itself function as a sort of signature of consciousness. But once we dissociate the NCC from the functional property, all bets are off. So I think what Chalmers has in mind here is that if you know that there are 40 Hertz oscillations in a creature, you can kind of use that to supplement the functional property you start with, variable report, global availability. So if you don't know whether the creature's capable of variable report or whether they have information that's globally available for the control of behavior, but you do know they have 40 Hertz oscillations, then you can ascribe consciousness on the basis of 40 Hertz oscillations. So you can use it to supplement a pre-theoretical measure, but you can't, he seems to be saying, you can't ever take it to trump information from the pre-theoretical measure. You can never really get beyond where you start, because your only reason to connect this with consciousness is via this. So you can never kick away the ladder that you're using to climb, to use a Wittgensteinian metaphor. I think it's Wittgenstein. That's the idea. So that's an articulation of a kind of pessimism. That's my focus, but I want to distinguish Chalmers' pessimism from a kind of quietism which you find in various people. I kind of think of it as a Wittgensteinian kind of position, but people who are not Wittgensteinians, like David Papineau, have places where they defend a kind of quietism. And the quietist says we can't go beyond our ordinary ways of ascribing consciousness, but that's okay because we don't need to. So that's the bit in which it's not pessimistic, because our ordinary ways of ascribing consciousness track it perfectly. There's no fact of the matter beyond our pre-theoretical patterns of ascription that we need to discover. So if we're not pre-theoretically clear about whether or not a creature is conscious, according to the quietist, there's no fact of the matter about whether they're conscious. It's just sort of a vague area. But you can't have a creature that really is conscious and yet we can't tell because our pre-theoretical measures don't get a grip on it. That's what the quietist denies. I don't want to say more about quietism, I just think it's an interesting position to note as distinct from pessimism. Okay, the optimist says there is no deep theoretical impediment to building a consciousness meter. We've built meters to measure electromagnetic radiation, water, gold, diseases like hepatitis. We can measure all sorts of things and go beyond our pre-theoretical ways of measuring them. Why not consciousness too? That's the optimistic position. Widespread view in the neuroscience of consciousness. Most consciousness scientists are optimists in some sense. Okay. So, section 2. The best way to defend optimism is to show that we've already built the consciousness meter. Right? If you can do something, then it must be possible to do it. That's the argument here. So what I want to do now is spend about 25 minutes, examining four experimental paradigms that people might take and in some cases have taken, to be forms of consciousness meters. And the background here is a series of papers or short articles by Christoph Koch. So if you've been reading Scientific American, as perhaps some of you do, you'll know that Christoph Koch has a column in Scientific American, and he's been talking about consciousness meters quite regularly. What do babies really know? A new study finds a possible brain signature of consciousness in infants as young as 5 months old. So brain signature is sort of in the same ballpark as consciousness meter talk. A new technique seeks to measure consciousness, an electromagnetic gadget to measure the level of consciousness. This is a more recent paper. So I'll talk about the study that he's got in mind here. Okay, but before I talk about these studies, I need to say a little bit about post-coma brain damage, because that provides the backdrop to these studies. So after people emerge from a coma, they transition through a couple of other states of altered consciousness. And these states are called disorders of consciousness. So one of them is called the vegetative state. You may have come across the term persistent vegetative state or permanent vegetative state. I'm just going to abbreviate here to vegetative state. The guiding idea here is there's no behavioral evidence of consciousness. And insofar as behavior is a good guide to consciousness, the thought is that these patients are not conscious at all. The vegetative state is distinguished from the minimally conscious state, where patients do show some behavioral evidence of consciousness. For example, they may track a moving object with their eyes. They may fixate on it, and then track it as it moves across their visual field. So they may show evidence of what's called visual pursuit. And that is thought, at least in some countries, not all, to be evidence of consciousness. So there's a philosophical question here. If I fixate on my finger, or your finger if you're the examining doctor, and if I pursue that object as it moves across my visual field, is that evidence of consciousness? Is it good evidence of consciousness? Is it any evidence of consciousness? That's one of the questions in the backdrop here. What's the relationship between simple behavioral capacities like that and consciousness? Third category is emerged from minimally conscious state, or EMCS, which is thought to involve a higher level of consciousness and involves functional communication, so communication between the doctor and the patient, and some kind of capacity for tool use. The key behavioral capacity that distinguishes the MCS from the VS states is responding to command. So if you're the doctor and I'm the patient and you say, look towards the right, and I do that systematically and consistently, then I'm responding to commands and I will be taken to be in a minimally conscious state. Okay, but because of all these, the way that these states are evaluated in the hospital are behavioral, and because there's a question about how closely behavior maps onto consciousness, there are obviously questions. One question is, might some vegetative state patients be covertly conscious? Right? Might they have experiences which they can't manifest behaviorally for some reason? And it's that question which has driven a lot of this research that I'm going to talk about. So that's a question to have in the back of your mind. The first paper is pretty famous. Some of you may have come across it, published in 2006. Lead author is Adrian Owen. And what he did was he had a 23-year-old woman who had been in a car accident, and she was in a vegetative state, so no behavioral response. No behavioral response is indicative of consciousness. Other than some visual object fixation and tracking, but no responding to commands, no behavioral response to commands. And they gave her two instructions on different trials. One instruction was, imagine playing tennis. Imagine yourself playing tennis. The other instruction was, imagine visiting the rooms of your house. So just imagine yourself walking around your house. And what they found was, when they gave these instructions to the controls, so they had 12 healthy controls in the lab, people working in the lab, they got activity in areas of the brain that you would expect given those kinds of instructions. So in the motor imagery, there's activity in the supplementary motor area, which is associated with motor imagery. So that's with the normal, neurotypical, healthy controls. And here's what you get with the patient. It's kind of a surprising, really quite an astonishing result. Activity in the same areas, and you can see here that her skull has been damaged. That's the patient. This way of presenting the data is not very helpful, I think, for many reasons. It looks like a photograph of the brain, but of course it's not. The colors are statistical representations of statistical significance. It's not a photograph. This is a better representation of the data. It's still not perfect, but it's better. So that's the tennis imagery trials. That's spatial navigation. The filled-in circles are the controls, the healthy controls, and the open circle is the patient. What's amazing is that she's within the normal range. She's towards the bottom of the normal range. But the astonishing thing is if you didn't know who the patient was and who the healthy controls were, if I said to you, if I filled all of those in and said, you tell me who the patient is, you wouldn't be able to do that. Now, lots of people, not everybody, lots of people think this is good evidence for consciousness in the patient. Remember, she's behaviorally vegetative. There's no behavioral manifestation of consciousness. The question for me here is the fMRI machine functioning as a consciousness meter? Is this an example of a consciousness meter? Well, to answer that question, we have to formalize the argument for consciousness in this patient. We have to do a bit of philosophical reconstruction. And there's different ways you might do that. Here's how I am tempted to do it. And here's the dominant interpretation of the study. The neuroimaging data indicate that the patient was following the instructions given to her. Instruction following is good evidence of consciousness, therefore the patient was conscious. That's not the only interpretation of the data, but it's a very appealing interpretation, I think. But note that it relies crucially on the second premise. Instruction following is good evidence of consciousness, and that appeals, I would argue, to a pre-theoretical measure of consciousness, a pre-theoretical conception of how consciousness and behavior are related. So the way I think of this argument is that it gives us what I want to call a derivative consciousness meter, kind of a second-class consciousness meter. It's derivative because it involves an information gathering device and a procedure that applies pre-theoretical bridging principles to generate a judgment about the presence or absence of consciousness. It's the pre-theoretical bridging principles, such as command following as evidence of consciousness or instruction following as evidence of consciousness, that makes it a derivative consciousness meter. So it's a consciousness meter in some sense because if you don't have the fMRI machine, you think she's unconscious. Once you have it, you can override that pre-theoretical judgment, and now you've got reason to think she is conscious. But it's a derivative meter because you're still relying crucially on this bridging principle that's part of our pre-theoretical conception of consciousness. Okay, second, before I get to the second study, let me contrast that kind of consciousness meter with a non-derivative consciousness meter, which involves an information gathering device and a procedure that applies non-pre-theoretical bridging principles to make a judgment about the presence or absence of consciousness. And I take it someone like Chalmers, who's an epistemological pessimist, is really only denying the possibility of this kind of consciousness meter. I think he would allow that you could use the fMRI in a derivative kind of way. So it's this kind of consciousness meter that I've really got my eyes on here. That's the focus of my interest. Okay. Second study also comes out of Owen's lab. It's a bit more complicated. I'm not going to talk about a lot of the complications. I just want to give you the general picture behind the study. So what they did in this study was they focused on a Hitchcock film, a short Hitchcock film called Bang, You're Dead, which you can see on YouTube. It involves this little boy, involves a little boy who finds a gun his uncle has just come back from Africa. There's a gun in his suitcase. The little boy finds it, and he runs around town pretending to shoot people who are working in shops. Everyone thinks this is very cute, very funny, because they think it's a toy gun. It's actually a real gun. It's got real bullets in it. He's playing Russian roulette, even though he doesn't know it. And it's classic Hitchcock. It's a great film to use as a stimulus. It's a very clever experiment because it involves a lot of suspense. You watch the film and you think, yeah, any moment he pulls the trigger, he could kill somebody. But nobody knows, everyone thinks it's a toy gun. And what's great about it is the suspense is driven by the plot. It's driven by the narrative content of the film. You have to know what's going on, and you know that people in the film don't know what's going on. It's very cognitive. Involves lots of theory of mind about what other people know, what other people don't know, what they would do if they did know what they don't know. It's very cognitive. It's not driven by suspenseful music. It's not driven by suspenseful emotional states associated with lots of explosions or quick editing. It's driven by the content, by the executive content of the plot. And what they did, don't worry about the words, I'm just interested in the pictures here. A is the brain activity of subjects, normal neurotypical control subjects, when they see the film in its original version. Don't worry about B. C is the activity when they see the film that's been spliced up. So you take a version of the film, you rearrange the ordering of the frame so that it doesn't make any sense anymore. You strip it of the narrative content, the narrative significance, but you have all the same kinds of auditory and visual information. You keep all of that, you change the plot, you get rid of the plot by changing the order of the frames. And D is what you get when you subtract C from A. So D is, as it were, picking up on the executive plot-following dimensions of the film. And then the more interesting comparison is between the healthy group and 2 vegetative state patients. That's really what's interesting in this film. So here you have measures of the auditory and the visual component of the film, or the processing. And these are 2 different ways, I won't go into the details, but 2 different ways of measuring the executive processing of the film. And then you look for the degree to which this activation predicts activation in the brains of the vegetative state patients, so two VAS patients. Patient 1, you get what you would kind of expect. A little bit of activation of auditory information here that's predicted. So the activation in the healthy group predicts a little bit of the activation you see in patient 1. In other words, it looks like he's maybe tracking a little bit of the auditory stimulation that's coming in, but that's about all. Patient 2 is here's the one that you get excited about, because it looks like what's being predicted here is not just the auditory and visual information, but a lot of the executive plot-following information. In other words, it looks like he's following the plot of the film. Okay, is this a consciousness meter in action? Again, we have to look at how you interpret the argument, interpret the data. Here's one interpretation. Patient 2's neural activity is best explained by supposing that he was following the plot. Plot following is good evidence for consciousness, so we have good evidence that patient 2 is conscious. Is it a derivative consciousness meter or a non-derivative consciousness meter? Is it like the previous case? Or is it giving us something deeper? Is it really going beyond our pre-theoretical measures? I would say it's just like the previous case, because we're just appealing to this pre-theoretical intuition that, following a Hitchcock plot, that's pretty high level. You've got to be conscious to do that. That's what's driving this interpretation. So I think this is an interesting result. Very good science. Does it really give us a consciousness meter? No, I would say. Only a derivative one. Okay. 2 more studies and then we'll get back to some philosophy. So this is another attempt to measure consciousness. And if this one's successful, then it really does, I think, give us a non-derivative consciousness meter. It turns on a distinction between two types of auditory irregularities. So we're going from vision here to audition. So here, imagine that the green rectangles represent low-pitched sounds, and the red ones represent high-pitched sounds. So you've got sets of 5 sounds, doot, 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 something like that, right? The 5th sound here is a local oddball. It's a local irregularity. But now contrast that sequence with a sequence which either goes like this at the end or alternatively goes like this at the end. Here we have a local deviant or a local oddball, but by the time you get here, you expect it. You've had a high-pitched sound at the end of each of these sets. By the time you get to the 5th set, you expect the 5th note to be a high-pitched one. But this is the oddball now, this set of 5, because this is the same as the previous 4. It's locally standard, but it's got a second order or global deviance insofar as you expect to go up, right? That's the expectation that's set up. And there's evidence from normal, healthy individuals that attention, and here we touch on some things that Francisco mentioned, that attention, that consciousness is required to detect the global or second order deviance. So that there's neural events that can be unconscious which can track local or the first order deviance. So there'll be a predictable regular ERP signal, or signal that's detectable by ERP, of local irregularity, but you need conscious attention in order to pick up on the second order or global irregularity, in order to be aware of that. So what folks have done is they've used this measure, this alleged measure of consciousness, to probe for consciousness in vegetative state patients. In other words, they play them the sequence of sounds. So on some trials it'll go like that, other trials will go like that, and they'll see whether there's neural evidence of detecting that this is not expected, that this is an unexpected pattern. And what do they find? So that's called the global effect, right? Evidence of a neural responsiveness to the second order or the global irregularity. So when you have emerged from consciousness patients, so these patients are clearly conscious, you get around 52% of those patients picked up on the global irregularity. And as you go back, as it were, down the levels of consciousness, you get fewer patients. But of course, the interesting thing is you're still getting 14%. So it's low, but some of these VS patients are showing the global effect. What do we do with that? What should we infer from that fact? Well, here's what the authors of that study said. And you can hear them struggling to do some philosophy at this point. Further studies will need to assess the sensitivity and specificity of the global effect as a test of consciousness. Although a small fraction of VS patients still showed a significant global effect, this need not necessarily imply a failure of our test, but rather may indicate the clinical label of VS may not be fully reliable. Right? I mean, you can see them struggling, right? These are non-behaviorally responsive patients, these 14% of patients, who show the global effect. Does that mean they're conscious, but not behaviorally responsive? Or does it mean they're not conscious, but yeah, sometimes under some conditions, some people will show this effect without being conscious? Which way do you jump? Right? Which is giving you misinformation? Which is your false positive? Which is your false negative? That's the problem. We don't yet, I think, have any good reason to treat this as a consciousness meter. It's suggestive, but what we need is some reason to privilege this over the absence of their behavioral response. Fourth study, and then I'll get back to the philosophy. And this is the study that's really exciting people. This is a study that Koch had in mind in talking about an electromagnetic gadget to measure the level of consciousness. Again, it's complicated. I'm just going to give you the nutshell. It involves what's called a perturbational complexity index. So what you do is you zap the brain with TMS. It's a bit complicated. First you do that, and then you use EEG to measure what they call the algorithmic complexity of the cortical response. What you're looking for is a widespread cortical response to the EEG, to the TMS zap, and one that's differentiated. So you want, as it were, different parts of the brain to respond in different ways, and not just to have a homogeneous, very simple response. So it's like throwing a coin in a pond. You want lots of parts of the pond to respond, but you want them to respond in different ways. The idea, it's driven by Giulio Tononi's integrated information theory of consciousness. And the idea is you're trying to capture the thought that consciousness is integrated and also differentiated. There's complexity, but there's a unity to consciousness. So it sort of starts with a phenomenological take on consciousness, and then it tries to capture that in terms of informational complexity in the brain, in the neural response. There's a lot you could say about the transition from this phenomenological characterization of consciousness to the algorithmic complexity that they used as a ground for the PCI. There's a lot of details you could talk about here. I'm just going to leave that to one side. We can talk about it in Q&A if people want. I'm interested in this slide and the next slide, and this is actually quite simple. It looks like a mess, but it's quite simple. Let me talk you through it. So, these different shapes represent different areas of the brain that they zapped with TMS. Different colors represent different intensity of TMS. For present purposes, I don't care about any of that. Here you've got, and so the PCI gets squeezed down into a number between 0 and 1. Right? That's, as it were, complexity of the neural response. Algorithmic complexity of the neural response. Some way of measuring that, and you squeeze that down to 0 and 1. Here you have 32 subjects. These subjects, 1 through 8, were zapped only when they were awake. So normal, awake, conscious subjects like you or I. And they're, irrespective of the location or the intensity of the zap, you get about 0.6, between 0.5, 0.6, something like this on this measure. Here, those subjects were also zapped while they were conscious, but some of them were zapped while they were sleeping, state of non-REM sleep. Some were zapped while they were on different kind of anesthetics. Over here we have Propofol, which is the anesthetic that killed Michael Jackson, in case you wanted to know. Okay, so then that summarizes that information, and you can see what's nice about this is a very clean separation between states that involve normal conscious wakefulness and the state of some degree of anesthetic or non-REM sleep. So it's pulling apart levels of consciousness. States which are probably involve an absence of consciousness actually, rather than just a low level of consciousness. So that's, as a comparison, that's the information from the previous slide. And then they did this very cool thing, was they applied the same measures to post-comatose brain damage patients. So over here, you have the vegetative state patients. Then you have the minimally conscious state patients, emerged from minimally conscious state patients. And here, just as a nice control, you have the locked-in syndrome patients. I haven't talked about locked-in syndrome, but it's a condition where people are clearly conscious. It's just that their capacity to control their behavior, the motor output, is offline. Usually they only have control over one eye or one eye blink. Sometimes even that's lost. But there's no doubt they're conscious. They can write books, they can communicate. It's just very difficult for them to open a communication channel. So these patients, as you'd expect, as you'd want, turn out to be as conscious as the control subjects. That's a nice result. And as you go up from vegetative state to minimally conscious state, you go from the kinds of levels of PCI that you get in the non-REM sleep and anesthesia, and around about MCS, you start to see heading towards the wakefulness, whereas these vegetative state patients are at the same levels of the unconscious patients. So it's cool. It's not a behavioral measure. It's objective, neuroscientific, and it's giving us something that looks like it sort of correlates nicely with what you get from behavior. Is it a non-derivative consciousness meter? That's really my question. It's a question I'm interested in. Well, here's what the authors of the study say. Reliably discriminated the level of consciousness in single individuals during wakefulness, sleep, and anesthesia, as well as in patients who had emerged from coma and recovered a minimal level of consciousness. PCI could potentially be used for objective determination of the level of consciousness at the bedside. Well, everything's being done by the word potentially here. It's suggestive. It's clearly suggestive. But do we have good reason to put a lot of weight on it? I mean, what's interesting is there's a kind of a contrast here between objective determinations that you get out of this kind of measure and the subjectivity which attends to behavioral examination of the patient. Behavioral examination is here. The implicit assumption is that subjective. It's not really scientific. This kind of measure is objective and scientific. That's the implicit contrast here. I think it's subjective, but the primary evidence for it, I think, is correlational. Now that's a little bit contentious because it's driven by Tononi's information integration theory of consciousness. So you might say the primary evidence is theory-driven, but his theory is highly contentious. We don't yet have good reason to adopt the theory. So the primary evidence for people who don't already accept the theory is correlational, and we lack clearly articulated grounds for using PCI data to supplement or trump our pre-theoretical measures. I don't think yet we have a situation where, suppose we had someone who's behaviorally MCS, but their PCI is way up here, right? Do we have reason to say, oh, well, they're conscious? It's suggestive, but I don't think we yet have reason to think the PCI measure of someone up here who's behaviorally MCS would trump the behavioral information we have. And that's what we would really need. So, what we need is philosophy at this point. We need a bit of philosophy of science, I think, and philosophy of mind. We need to articulate a methodology which really might enable us to provide the theoretical grounds for the kind of work that I've talked about. And the best picture that I know of is developed by my friend and collaborator Nick Shea. Picture of him here. We talked about this a little bit in a paper we wrote a few years ago, and since then Nick has written about it more extensively in a paper that came out in Philosophy and Phenomenological Research, and he calls it the natural kind method. So this, I think, is a method which would give the scientists the kind of theoretical foundations that they're looking for. How does the natural kind method work? Well, the basic idea is you treat consciousness as a natural kind. So here we tie up quite nicely with things that Francisco left dangling at the end of his talk. Like gold, like water, like hepatitis. And you look for independent measures of it in the way we have looked for and found post-intuitive, right, theory-driven measures of water, hepatitis, and the like. And how do you do that? Well, you look for nomological clusters, that is, law-like clusters between putative tests of the phenomenon. A set of properties forms a nomological cluster if they're instantiated together better than chance, and if observing subsets of the cluster supports induction to other members of the cluster. I mean, that's the point of a natural kind, right? It robustly grounds induction. It gives you a difference between inductions and inferences involving water and those involving, or even properties like being green and being blue, and properties like being GRU. Right? So one of the lessons from the Goodman's new problem of induction is that you need to use natural kinds in your inductive method. That's sort of the conception of natural kinds that's driving this project. Right? Anything that will really ground inductive inference. Once you've identified the nomological cluster, you then look for the natural kind, or what Ruth Millikan would call the real kind, to which the members of the cluster are causally or constitutively related. So there's a debate yeah, the philosophy of science, the philosophy of natural kinds, about whether the underlying kind is causally related to the members of the cluster, whether it's constitutively related. I want to set that to one side. It doesn't really matter. Doesn't really matter for present purposes. And once you've got that, you're in a position to supplement and trump your pre-theoretical ways of detecting the relevant phenomenon. Right? You can go beyond the pre-theoretical ways, which are going to be tied up with the elements of the cluster, and look for the presence of this underlying or real kind. With respect to consciousness, you could apply the natural kind method at various levels of analysis. So I come back to the taxonomy I started with. You could treat consciousness as a natural kind. That's the cleanest, most straightforward approach. Or you could focus on fine-grained experiences, particular contents. And you could ask, is visual experience a natural kind? Is the visual experience of red a natural kind? Is pain experiences, are they natural kinds? Or you could focus on these global conscious states, these levels of consciousness, and ask whether they're natural kinds. And it may turn out that the natural kind method is useful at some levels, but not at others. That some of these things turn out to be natural kinds, whereas others don't. Lots of open questions in how comprehensive the natural kind approach can be. Let me leave those questions to one side and just finish. Got 10, 15 minutes left? Yeah, 10, 15 minutes to discuss 3 challenges to this whole approach, 3 philosophical challenges. And I'm going to discuss them in increasing order of worryingness. So the ones at the start, they don't worry me too much. The one at the end keeps me awake at night. Here's the question, can the natural kind method really provide the foundations for a non-derivative consciousness meter? Here's the first objection. I call it the objection from impotence. We know that in difficult cases, like non-human animals, vegetative state patients, the fetus, some of the pre-theoretical features associated with consciousness will be present and others will be absent. That's kind of what makes them difficult cases. Right? They're not like bricks, where none of the features are present. They're not like neurotypical human beings like me or you, where all of the features are present. They're sort of in the middle. So in such cases, we cannot expect the natural kind method to deliver an unequivocal verdict regarding consciousness. Why? Because some of the features are going to be present, some of the features are going to be absent. And so the natural kind method cannot render the difficult cases any more tractable, cannot make them easier to solve than they are without it. We don't make any progress with this method. They're still going to be as difficult as they were when we started. That's the first objection. Here's my response to it. There's got to be something wrong with the argument. Why? Because we know the natural kind method can settle difficult cases when it comes to water, gold, hepatitis. Right? Suppose we don't know whether I have hepatitis. I've got some of the features, some of the symptoms, but other symptoms are missing. Right? My mom looks at me and she says, "Oh, I think you might have hepatitis." My dad looks at me and says, "No, I don't think you've got hepatitis." Right? We're not sure. Well, we do a clinical examination, we see what that results shows, and it will usually deliver a verdict as to whether or not I have hepatitis. Right? If we have a gold watch or some gold ornament, and we're not sure whether it's gold, well, we can do a chemical analysis and it will deliver a verdict. So there's got to be something wrong with the objection. What's wrong with it is we put more weight on the underlying property that regulates the nomological cluster than we do on particular elements of the cluster. And that underlying property can be present or absent when only some of the members of that cluster are present or absent. So if I have if we have the chemical features of gold, then it's clearly gold, even if some of the ordinary superficial properties are missing. Right? That's why you can have things which look like gold but aren't gold, and you can have something that's gold but doesn't look like gold. So, it's not obvious why you couldn't have the natural kind method, why the natural kind method couldn't underwrite the construction of a consciousness meter, something that, as it were, delivers a verdict about the difficult cases. That's the first objection. Here's a better, I think, more worrying objection, which I call the starting point objection. How do we select the properties that we interrogate for the nomological properties? I mean, how do you get going? How do you start? Here's the tempting thought. You've got to begin with what Chalmers would call the primary intention, or other people might call what's analytically contained within the concept. Those features that are associated with the property a priori. We don't have to appeal to what's analytic here. Some people don't like the analytic-synthetic distinction. We can just talk about what's associated with the property, with the concept a priori. Interrogate those features, you look for nomological clusters amongst them, and then you, as it were, follow your nose. That's the tempting thought. And then there's a second thought. You could argue that when it comes to consciousness, or when it comes to phenomenal consciousness, there are no substantive features that are a priori associated with the concept. All there is this talk of what its likeness, which is not functional. It's not physical, it's not functional. That's the whole point of distinguishing access consciousness from phenomenal consciousness, in a sense. Access consciousness is the kind of consciousness that there are substantive features associated with the concept a priori. Phenomenal consciousness, it's, well, what's that famous quotation from Bloch's paper? It's like Louis Armstrong says when you've got to explain jazz, if you don't recognize it, you ain't gonna, if you got to ask, you ain't ever gonna get to know. You just lock onto the concept directly, and not because it's associated with any substantive explanatory functional features. You just sort of recognize it when you see it. Which is why people like Nagel, Chalmers, Jackson, Bloch, when they're talking about phenomenal consciousness, they give examples. Pain, visual experiences. That's how you're meant to lock onto the concept. That's how you're meant to grasp it. It's definition by extension rather than definition by appeal to any substantive features. Here's another way to see the point. It's the same point from a different angle. Natural kind concepts secure their reference indirectly by some sort of opaque mode of presentation, maybe a description or something like a description. And they're inferentially integrated with other functional or physical concepts, whereas phenomenal concepts, here again Francisco's connections with Francisco's talk, phenomenal concepts, there's a concept, all phenomenal consciousness are a specific kind of concept. The thought is, they're transparent, they refer to their reference directly, and they're not inferentially integrated with other functional physical concepts. Right? They're sort of somehow direct in ways that different theorists spell out in different ways. And the worry is that the natural kind method could be successful only if consciousness were a natural kind concept, and it's not. That's one of the lessons people have drawn from all the discussion about the knowledge argument, Mary in her black and white room, the explanatory gap, that to respond to those arguments for dualism, you've got to have a particular theory of phenomenal concepts. Here's the response I'm tempted to make. All that the natural kind method requires, by way of a starting point, is that phenomenal consciousness actually is a natural kind. You don't have to think of it as a natural kind. It just has to be a natural kind. And there's no demand that we latch onto the various elements of this nomological cluster in any particular way. That's the thought. So here's a meta-analysis, or as it were, just a survey of different ways of measuring consciousness in epileptic absence seizures. I love this slide, because you can't really see what's going on, but it makes the point. So, you could study consciousness in epileptic absence seizures by asking people questions. So this is verbal response to questions, responding to command, reading aloud, counting aloud, short-term memory, choice reaction time, responding to mild or vigorous stimuli, asking people to engage in some sort of repetitive tapping. All these different ways of measuring consciousness. And they dissociate in interesting ways. They associate in interesting ways. Which of these is analytically or a priori associated with consciousness? I have no idea. I mean, I don't know. Are any of them? The natural kind method says it doesn't matter. Just look at all the stuff. It's associated with consciousness somehow. Interrogate it for nomological clusters, and then look at what's underlying regulating those clusters. That's how you might latch onto consciousness. Okay. Here's yet another way of getting the same point. There's an intentional notion of a natural kind concept and an extensional notion. In the intentional notion, it's a concept that's taken by those who possess it to refer to a natural kind. It's part of, as it were, the possession of a concept that you think of it as a natural kind concept. Extensional notion is a concept that in fact refers to a natural kind, whether or not it's part of the, as it were, logic of the concept that it does so. And the natural kind method says all that's required is that it be extensionally a natural kind. You don't have to, as it were, think of it as an intentional natural kind. That's the thought. Okay, final objection. It's really two objections in one. Here's the objection. We possess a distinctive form of first-person authority with respect to consciousness. Natural kind method cannot accommodate this distinctive kind of first-person authority, so the natural kind method is not viable. It's valid. If the premises are true, the conclusion has to be true, so that's good. But are the premises true? Here's the premise that I'm going to focus on, and I want to explicate it. I want to develop it by looking at two manifestations of this distinctive kind of first-person authority. Here's manifestation one. There's no genuine threat, or as I'm more inclined to say, no scientifically grounded threat of eliminatism or divided reference when it comes to consciousness. So, other natural kind terms, clearly natural kind terms, like phlogiston, jade, hepatitis, do involve some kind of threat of eliminativism or divided reference. So phlogiston, the standard story is it turns out not to refer to anything. Jade, there are two types of jade that it, as it were, refers ambiguously to. Hepatitis, there's three different types of hepatitis. And we sort of now distinguish hepatitis A, hepatitis B, and hepatitis C. The natural kind method seems to bring with it the possibility that either there won't be a natural kind underlying the various properties we associate with consciousness, or there might be various different kinds, consciousness A, B, and C, on the model of hepatitis A, B, and C. But both of those possibilities seem to me to be really, really implausible. And here I want to contrast consciousness with attention. So one move you can make with respect to the kind of work that Francisco was discussing with respect about attention and unconscious attention and different kinds of attention is to say, well, there's really different types of attention. And there's no single thing of which they're all types. There's no single kind here. With respect to attention, I find that a kind of a plausible view. I'm not sure if it's true, but it seems to me one that ought to be taken seriously. I don't find the same attitude to consciousness all that compelling. So insofar as I really want to hold on to, and maybe I'm not alone, the idea that these are not real possibilities. That we know from the first person perspective that consciousness is a unitary kind. That puts some pressure on the natural kind methodology. Second objection. Well, second manifestation of the tension between the first person and the third person perspective. There's no genuine threat of Foole's phenomenology. So what do I mean by that? Well, suppose you wake up one morning and you look in the mirror and you see that your eyes are jaundiced, your eyes are yellow. You think to yourself, I've got hepatitis. Well, it may not be hepatitis. It may be fool's hepatitis, like fool's gold. It may be some other disease that is masquerading as hepatitis. It has some of the superficial characteristics of hepatitis, but it isn't hepatitis. You just happen to have jaundiced eyes. You're mistaken. First person, your self-attribution is mistaken. You take yourself to have a property that you don't have. Right? And you look at the virus. Whether or not you have hepatitis depends on whether or not you have the virus associated with Hep A, or hepatitis B, or hepatitis C. But now take a case of self-ascription of a conscious property. So you wake up one morning and you think, I've got a headache. Could there be fool's headaches, fool's phenomenology? Things that from the first person perspective seem like headaches, but they're not headaches because the natural kind property is not present. It's less easy to see how that might go. Right. Other people can manifest headaches without actually having a headache. They can be good actors. But in the first person case, your acquaintance with your own phenomenology seems to prevent the possibility of fool's phenomenology in the same way. I don't want to say introspection's infallible. And when I've given this talk before, people say, you say introspection's infallible. I'm not saying that. I didn't say that. I don't believe introspection's infallible. But there doesn't seem to be the same kind of room for mistakes about what conscious states you're in right now, for mistakes about the self-ascription of conscious properties that there is for other things that we think of as natural kinds. All right? So if I take myself to be in pain, generally speaking, the thought would be we're very reluctant to think that fMRI evidence or other kinds of evidence might undermine that self-ascription. Okay, where does that leave us? So this is the third. Where does this third objection leave us? Two options, I think. We could surrender, we could give up on any kind of distinctive first-person authority as the price to pay for a mature science of consciousness. Or we could hunker down. Some people want to hunker down. Some people want to set up their camp and defend first-person authority to the last breath. Treat canonical deployments of phenomenal concepts as essentially connected to the underlying natural kind, and then you've got a kind of gold standard before you've done the science. You've kind of said, I don't care how the science is going to come out. Here's my starting point, and I'm not going to give this up. We have a kind of privileged access to consciousness from the first-person perspective, which doesn't mean we're infallible, but we have a kind of privileged access. I would like to hunker down. I don't find surrender attractive, but then the question is hunker down really consistent with the natural kind method? And I fear the answer is no. So that's my problem. That's what keeps me awake at night. If you are happy to surrender, then no problem. You can embrace the natural kind method. If you reject the natural kind method, it's fine to hunker down. If, like me, you want to hunker down but also embrace the natural kind method, then I think you've got a problem on your hands. And that's where I'll end things. Okay. Thank you very much.